Hello friends, Namaskar, this is Sanjay. The CTET December 2021 examination was conducted from the 16th of December till the 21st of January of 2022. So there are 23 different versions of paper 1 that we can solve from this exam. Since we will be solving 30 questions per subject from these question papers, we will be solving 690 questions per subject in this complete series. In this video, we will be solving the 30 mathematics questions from the paper 1 that was conducted on the 5th of January of 2022. So let us get started. And by the way, all these videos are available in both English and Hindi versions on our channel. What should be subtracted from the sum of 9599, 5995 and 9995 to obtain 1995? This is a very simple question. If you look at it this way, if you know 3 minus 2 is equal to 1, then if you switch them around, then 3 minus 1 is equal to 2. So here we have to do the same thing. First add up these three numbers. We will get 25589. So from 25589, if we subtract 1995, then we will automatically get the answer. So 25589 minus 1995, and the answer is 4, 9, 5 and 5. So 5594 is the correct answer. Which one of the following represents the number 55,55,555? This is again a very simple question. First, look at what is 1 lakh. 1 lakh is nothing but 1 followed by 5 zeros. So if we have to write 55 lakhs, then it will be 55 followed by 5 zeros. So the answer should have 5 plus 2, that is 7 digits in it. Now if you look at all the given options, only the first one has 1, 2, 3, 4, 5, 6 and 7 digits. Therefore this is the correct answer. Kusum plays with her friends in the evening when both the hands of the clock are at 6. This time on a 24-hour clock can be read as what? This is a very simple question, but there is a small error in this. That is, both the hands of the clock are at 6. Now this is impossible if the clock is working properly, because you can take a clock and check out that if the minute hand is on 6, then the hour hand will always be between 2 digits. So it is not possible to have both the hour hand and minute hand on 6 at any point. Right? But if this question is just saying that the hour hand is near 6 and the minute hand is on 6, then what would be the time in 24-hour clock? So if the hour hand is close to 6 and the minute hand is on 6 like this, then it would be 6:30. Now this 6:30, is it in the morning or evening? If it is morning, it will be 6:30 AM, right? Whereas if it is in the evening, then in the 24-hour clock, it will be 18:30. So since they have mentioned that this is in the evening, the answer has to be 18:30. The sum of the fractions 3 by 15 and 7 by 12 is what? So you just have to write 3 by 15 plus 7 by 12. So to add this, you have to take the LCM of 15 and 12. So 15 and 12, if you look at the least common multiple, then 5 3s are 15 and it will be 12. Then 3 1s are 3, 3 4s are 12. Then 2 1 right here, and then 2 2s are 4. So which means that the LCM of 15 and 12 is 5 into 3 into 2 into 1 into 2. So which will be 15, 30 and 60. So it will be 60. So now if we write 60 here, then 15 4s are 60. Therefore 3 into 4, that will be 12, plus 12 5s are 60. Therefore 7 into 5, 35. So 35 is equal to 47 by 60. Therefore the correct answer is 47 by 60. A square has a boundary of 20 centimeter. From the corners of this square, a small square of side 1 centimeter is cut off. What will be the change in the boundary of the new shape? So here initially we had this square, right? So this square had a boundary of 20 centimeter. So which means that each side will be 5 centimeter, right? And if we cut off squares of 1 centimeter from each corner, so which means that we are cutting off this square, which is 1 centimeter and 1 centimeter. So now every time you cut off one square like this from a corner, you are removing -1, right? You are removing 1 centimeter from each side. However, you are introducing 1 centimeter and 1 centimeter on the other sides. Therefore, the net effect on each corner will be 0. So even here, you are removing 2 centimeters and adding 2 centimeters. So if the net effect on each corner is 0, then the net effect on the entire operation will be 0. Therefore, if the original square had a boundary of 20 centimeter, then after we have cut off these squares of 1 centimeter into 1 centimeter from each corner, then the remaining figure will have a boundary of 20 centimeters itself. Therefore, option 3, which says the boundary of the new shape will be equal to the boundary of the square, is the correct answer because the boundary will not change. 5 students measured the lengths of their pencils using a scale, and the results were as follows. Right? So there is a set of 5 numbers that is given here. So now what is the average length of all these pencils? So we have to add these 5 numbers and divide them by 5 because there are 5 distinct pencils here, right? Then we will get the correct answer. So if we add 15.5, 12, 11.8 and 9.7 and 7, right? So we will get 0, 2, then 6, 5. So we'll get 56 here. Now we have to divide this 56 by 5. So 5 ones are 5, 5 ones are 5, 0.0, so 5 twos are 10. So which means the answer is 11.2. So 11.2 is the correct answer. 18 squares of side 2 centimeter each can cover a currency note. How many squares are required to cover 3 such notes? So now to cover one note, we need 18 squares. So to cover 3 notes, how many do we need? So we just have to do 18 into 3, that will be 54. So the answer is 54. Identify the quadrilateral. I have 2 lines of symmetry and all my angles are 90 degrees. So if all the angles are 90 degrees, then it has to be a square or a rectangle. Now it says that I have 2 lines of symmetry. If we draw a line of symmetry on a square like this first, right, which means that if we fold a square along this line of symmetry, then both the sides will perfectly match or perfectly coincide. So similarly, we can draw a line of symmetry like this as well. That is, both the sides will perfectly match. Or we can draw a vertical line of symmetry, or we can also draw a horizontal line of symmetry. So 1, 2, 3 and 4. A square has 4 lines of symmetry. Now in a rectangle, if we draw a line of symmetry here and you fold both of these sides, they will perfectly match. If you draw a vertical line of symmetry, both these sides will perfectly match. However, if we draw a diagonal line like this, then that is not a line of symmetry because this and this will not perfectly match. So both these corners will not align. Therefore, a rectangle has only 2 lines of symmetry. Now, since answer has to be square or rectangle, and the first statement says I have 2 lines of symmetry and rectangle has 2 lines of symmetry. So the answer has to be option 3, that is rectangle. Shirts in 4 colors, that is blue, yellow, black and white, are available in packets of 5, 10, 12 and 15 respectively. If a shopkeeper wants to buy equal number of shirts of each color, what is the minimum number of packets of different colors he should buy? So if the shirts are available in packets of these numbers, that is 5, 10, 12 and 15, and if we need equal number of shirts of all these 4 colors in our shop, then we have to take the lowest common multiple, that is the LCM of these 4 numbers. So let's calculate the LCM of these 4 numbers, that is 5, 10, 12 and 15. So 5 ones are 5, 5 twos are 10, 5 threes are 15. Next, let us do it with 3. 3 fours are 12, 3 ones are 3. Then let us do it with 2. 2 ones are 2, 2 twos are 4. Right? So which means that the LCM of these 4 numbers is 5 into 3 into 2 into 1 into 1 into 2 into 1. So 5 3s are 15, 15 2s are 30, and 30 2s are 60. So the LCM will be 60. Now how can we divide 60 with these numbers? So 5 into 12 is 60, therefore it has to be 12 here. Then 10 into 6 is 60, so it has to be 6 here. Then 12 into 5 is 60, therefore it has to be 5 here. And 15 into 4 is 60, so it has to be 4. So option 3 is the correct answer here. If the shopkeeper buys 12 packets of blue shirts, 6 packets of yellow shirts, 5 packets of black shirts, and 4 packets of white shirts, then he will have 60 shirts of each color in his shop. Renuka decided to use nails and a rope to make a circle in the ground. She took a thin rope and tied nails on both ends of the rope. Then she made a circle with the help of her friend. Which of the following statements is correct in the given situation? So what did Renuka do? Renuka took one nail and she tied a rope, and there was a nail on the other end. So she turned this around on the ground and she made a circle. So now which of these statements is correct? The length of the rope used is equal to the length of the chord of the circle. So what is a chord? Chord is this. No, the length of the rope is less than the chord of the circle. The length of the rope is equal to the length of the diameter of the circle. Now what is the diameter of the circle? Diameter is exactly in the center and it goes from end to end. Now if you notice, the rope is half of the diameter. It is not equal to the length of the diameter. Therefore this option is also incorrect. Then the length of the rope is equal to the length of the radius of the circle. This is correct because when you tie a nail and you turn it around like this rope is essentially the radius of this circle. Therefore this is correct. Next, the length of the rope used is equal to the length of the circumference of the circle. Now the circumference is much bigger than this rope. Therefore this rope is not equal to the length of the circumference. So this option is incorrect. How many total or complete packets of 3/4 sugar can be made from 51 2/3 kg amount of sugar? So this total or complete is indicating that any fractions or decimal points can be ignored when we do the calculation for this problem. So now here we have 51 2/3 kgs of sugar. So that is 51 2/3 kilos. Now we have to divide this with 3/4 because we have to make packages which have 3/4 kilos them. So let us simplify this fraction. So 51 3s is 153 plus 2 is 155. So 155 by 3 divided by 3/4, which means that 155 by 3 into 4/3. Since we can't easily divide anything here, let's multiply it and simplify it further. So 155 into 4 is 620 and 3 into 3 is 9. So now we have to divide 620 with 9. So 9 6 are 54, we'll get 8, 0, 9 8s are 72, 8. Now 8 is less than 9. Therefore, if we do the further division, we'll have to put a point and take a 0 and do all that. But we have been told that we have to look at only total or complete packets. So we can stop at 68. So if you look at the answer choices, option 2, which says 68, is the correct answer. So if we divide 51 2/3 with 3/4, we get 68 full packets, and then we'll get some decimal points or fractions which we can ignore. Which of the following statements is correct? Now, is 1 a prime number? So what is this prime number? A prime number is any number like 2 or 3 or 5 which is divisible by itself or by 1. Like 3 is divisible by itself or by 1. So 5 is divisible by itself or by 1. So they don't have any other factors. They have only two factors, which are the number itself and 1. So is 1 a prime number? When we look at 1, 1 is divisible by only 1. Therefore, it does not have two factors. Therefore, 1 is not a prime number. Is 1 a composite number? Well, what is a composite number? We have seen what are prime numbers. Prime numbers have two factors, itself and 1. Composite numbers are numbers like 6, which have more than 2 factors. For example, 6 can be divided by 6, it can be divided by 3, it can be divided by 2, or it can be divided by 1. So 6 has more than 2 factors. Therefore, 6 is a composite number. As you have seen, 1 can be divided only by 1. Therefore, 1 is not a composite number. And 1 is both a prime and a composite number. If 1 is not a prime number and 1 is not a composite number, then 1 cannot be both a prime or composite number. Therefore, the only correct answer is option 4, which is 1 is neither a prime number nor a composite number. The angles of a triangle are in the ratio of 5:6:7. What is the measure of the smallest angle? Now, the angles of a triangle will always add up to 180 degrees. Right? So if they are in the ratio of 5:6:7, so let's add these three. So 5 plus 6 plus 7 will get 18. So if we divide this 180 with 18, we'll get 10. So the smallest angle is 5 into 10, that is 50 degrees. And the next angle is 6 into 10, that is 60 degrees. And the third one will be 7 into 10, that is 70 degrees. Therefore, the smallest angle here is 50 degrees. And option 2 is the correct answer. Bimal bought a packet of candies on his birthday. He gave 1/3 to John, 1/4 to Radha, 1/5 to Sushmita, and 1/6 to Miku. He ate the remaining 6 candies. So how many candies were there in the packet? Now this is actually a simple question, but it requires some calculations. So if you can follow the steps that I've used and understand the calculations, then you'll be able to solve any such questions quite easily. So let's write this entire problem in the form of an equation. Since we don't know what is the original number of candies that were there in the packet, let's take it as x. Now Bimal started giving away candies. So first he gave 1/3 to John. So that will be x minus x into 1/3. Then he gave 1/4 to Radha. So that will be x into 1/4. And then 1/5 he gave to Sushmita. So that will be again minus x into 1/5. And he gave 1/6 to Miku. So it is minus x into 1/6. And how many candies were remaining after that? So that balance was 6 candies which he ate. So now we have to simplify this equation. To simplify this, first let's write x and take this minus x which is there in all these 4 parts of the equation. Let us take it out. So we'll get x minus x, and the signs of the fractions here will change, right? So that will become 1/3 plus 1/4 plus 1/5 plus 1/6 is equal to 6. Now to add these 4 fractions, we have to take their LCM. So the LCM of 3, 4, 5 and 6 is what we need to calculate. So first let us do it with 3. 3 1s are 3, 4, 5, 3 2s are 6. Next let us do it with 2. 1, 2 2s are 4, 5 and 1. So 3 2s are 6, 6 2s are 12, 12 5s are 60. Therefore, the LCM of these 4 numbers is 60. So now let us write it in the calculation, that is x minus x divided by 60, and because 3 20s are 60, it will be 1 into 20, therefore 20 here, and then 4 15s are 60, therefore plus 1 into 15, so it will be 15, plus 5 12s are 60, therefore 1 into 12, so therefore 12 here, and 6 10s are 60, therefore this will be into 10, so plus 10 is equal to 6. So now if we add these 4 numbers, right, what do we get? We get x minus x into 57 divided by 60 is equal to 6. So now to simplify this, let us multiply all of these different parts with 60 so that we can take out this 60, eliminate it, right? So it will become 60x minus x into 57, because we have multiplied this with 60, this 60 goes off, gets cancelled, is equal to 66 into 60, that is 360. right? Therefore 60x minus 57x is equal to 360 is what we are getting. Therefore that is 3x is equal to 360 because 60x minus 57x is 3x. So if 3x is 360, then for x is equal to 360 divided by 3. Therefore that will be 120. Therefore x is 120, which means that the packet originally had 120 candies, which he distributed to everybody and he ate the balance 6. So the original number was 120. So answer option 2 is correct. The sum of 7 consecutive numbers, even numbers, arranged in increasing order is 98. What is the third number in this order? Now there are multiple ways of solving this problem. You can use the algebraic method where you say that the first number is x, then the second number is x plus 2, then the third number is x plus 4, then the third number is fourth number is x plus 6. So that way you can write an equation and solve it. Now that would be more required if we were dealing with the odd number of consecutive numbers, right? But here we are dealing with even number of even consecutive numbers. So we are dealing with 7 consecutive even numbers. So there is a very simple way of solving this problem. We know that the sum of these 7 consecutive even numbers is 98. So which means that if we divide this 98 with 7, we'll get the average of all these 7 numbers, right? So that's how averages work. So if we do it with 7, 7 ones are 7, 2, 8, 7 fours are 28. So 14 is the average of these 7 consecutive even numbers. Now since there are 7 numbers, 1, 2, 3, 4, 5, 6 and 7, this average 14 will be the number that is exactly in the middle of this sequence, right? So exactly in the middle will be 14. Now since these are 7 consecutive even numbers, which means that the next number after 14 will be 14 plus 2, that will be 16, and then it will be 18, and then it will be 20, which means that the number before 14 will be 12, then it will be 10, and then 8. So now we have been asked to identify what is the third number in this order. So the third number is 12. So option 1 is the correct answer. So you can solve this using the algebraic method, or you can use a common sense method to solve the problem, especially if you are dealing with odd number of consecutive numbers. The following 3 statements have been given in the context of teaching numbers to students of early primary classes. First one says, encourage students to think about numbers and quantities of objects when these are meaningful to them. This is a correct statement, because if children can understand the context of what they are doing when they are counting numbers or quantities, then they'll be able to understand mathematics better. So contextual teaching means that the subject that they are learning and the topics that they are learning and the activities must be meaningful. If you just tell somebody about trigonometry, right? So now unless the person actually knows what is trigonometry, why is it being used, and why should I learn that, that person may not have that much of interest in learning trigonometry. Therefore, if you make it meaningful, and if you tell him why is he learning it and what is the purpose, where is it is used, then he'll be able to better understand mathematics. So encourage students to think about number and quantities of objects when they are meaningful is contextual learning. So this is a correct statement. Next, encourage students to learn counting by recalling number names. So recalling number names means that children are just memorizing something and recalling it. So this is not useful, right? And the last one says, encourage students to make sets with movable objects. So if you have seen how mathematics and counting especially is taught to small children, then they use blocks or they use other objects to make numbers or like make groups, and that's how they learn counting. So this is also very useful. Now A and C are correct. They are useful in the context of teaching mathematics and teaching numbers, whereas B is not a correct approach. Therefore A and C here is the correct answer. Which of the following represents the correct sequence of the geometrical reasoning levels according to Van Hille's theory? Now Van Hille's theory is quite important because every year you'll see at least 1 or 2 questions based on this theory. Now, there are 3 main types of questions that you can see. One type is this, where you'll be asked to identify the correct sequence or the correct order of the geometrical reasoning levels. Or you might be given the level, that is, they might tell you that the child is good at analysis. So they will ask you, what is the meaning of this? If the child is good at analysis, what can the child do? So the answer will be the ability of the student. Or they might tell you the ability of the student. For example, the child is good at describing shapes on the basis of their appearance. So the child is at what level? So they might ask you to identify the level based on the ability. So these are the 3 main types of questions that you will see on the basis of Van Heel's theory. Now, in this question, they are asking us to identify the correct sequence. So the first is visual or visualization. Then it is analysis. Then it is abstraction, or it is also called relationships. Then there is deduction. And then there is rigor or axiomatic. So if we look at the answer choices, since visualization is first, only options 1 and 3 have visualization as the first one. So we can eliminate options 2 and 4. The next one is analysis. So when we look at it, only option 3 has analysis at the second level. So we can eliminate the first option as well. So let us just verify that option 3 is correct. So first is visualization. Next it is analysis. Then there is relationships. And then there is deduction. And the last is rigor or axiomatic. So this is the correct answer. Which of the following statement is not appropriate for mathematical tasks? The first statement says, when students are challenged with appropriate mathematical tasks, there is a probability that they become confident in their ability to handle difficult problems. This is a correct statement, because when class 3 students or grade 3 students are given problems which they are able to solve at their level, right? So as they solve more and more problems, they will become more confident, right? And they will start to appreciate the subject. So that way, children should be challenged with appropriate mathematical tasks. You should not give a grade 6 or a grade 7 kind of a problem for a grade 3 student, right? And you should not give a grade 3 problem to a grade 7 or a grade 8 student, because then it will be very easy and boring for them. Therefore, you should give them appropriate mathematical tasks. So this is a correct statement. Next, if mathematical task is difficult, it cannot be engaging for the students. No, this is absolutely incorrect. This is incorrect because students like to be challenged. You have to make it interesting. You have to make it challenging. You have to make it a little difficult, because if it is too easy, then children will get bored. Therefore, it cannot be a blanket statement just because it is difficult, it will not be engaging. Right? Therefore, this is an incorrect statement, and we have to identify which one is not appropriate. So that will be option 2. The next one says mathematical tasks should encourage students to become autonomous learners. This is a correct statement, because when you teach students the basics and give them good amount of mathematical tasks at their level, the idea should be that going forward, they should be able to function independently. They should be able to learn independently wherever possible. They should become autonomous, right? And it should not always be driven by the teacher. The students should take interest, they should learn, and they should be able to do things independently. That is the meaning of autonomous. And the last one, mathematical tasks should provide flexibility for exploring alternative paths to solve the problem. This is also a correct statement. As we have seen, there can be more than one method to solve a problem. And students should be encouraged to explore all these different methods of solving the problem and not just follow blindly whatever the teacher has prescribed. Therefore, mathematical tasks should provide that flexibility for exploring alternative paths. So, statement 1 is correct, statement 3 is correct, and statement 4 is also correct. Only statement 2 is incorrect and not appropriate. Which skill is expressed in the following statement that will help a child understand the quantification of objects? The child mentally includes 1 in 2, 2 in 3, 3 in 4, and 4 in 5, so on and so forth. So here what is being mentioned is that if the child is talking about 2, then the child is mentally including 1 also in the 2, because if I say 2 chocolates, it means that there is already 1 chocolate and this is the second chocolate. Similarly, if I say 3 chocolates, then it means that there is a second chocolate and before that there is also a first chocolate. Only then there will be 3 chocolates. So this way, the child is mentally including 1 in 2, 2 in 3, 3 in 4, 4 in 5, so on and so forth. So now this is hierarchical inclusion, right? Because when I say level 1, it means that level 2 is also included in it, right? When I say level 2, it means that level 3 is also included in level 2, right? And when I say level 3, then it means that level 4 is also included here. So when I say level 1, it means that level 2 is also included in it, level 3 is also included, level 4 is also included. So this is a hierarchy. So the answer here is hierarchical inclusion. In this question, we are being asked which of the following is the most appropriate strategy for introducing concept of fractions in primary mathematics class. Now in primary mathematics class, children have just learned the concept of numbers, and now we are trying to introduce the concept of fractions. So if we give the problem as a word problem, right? So then first thing is they will have to understand word problems, then they have to convert it into a mathematical problem or write it in numbers, and then they'll be able to understand it or solve it. So this is quite complex. Right? So this cannot be the most appropriate way of introducing fractions at primary mathematics class. So this can be eliminated. Next, showing a picture chart representing half and 1/4. Right? Now, if they don't understand the concept of fractions properly, then just showing them a picture chart with the representations of half and 1/4 might be useful to a certain extent, but it is not the best way to introduce the concept of fractions. So this also can be eliminated. Next, representing the fraction on a number line. Now here again, children have just learned the concept of numbers. So if you show them a number line and see how fractions can be represented on a number line, that is quite complex for primary mathematics classes. Therefore, this also can be eliminated. Now, one of the basic things about learning mathematics is if you do something hands-on, right, then you are able to understand it better, you are able to learn it better. So the last option, which says doing paper folding activities with symmetrical rectangular strips and circular cutouts, is the best way to introduce the concept of fractions at primary mathematics classes. This is the correct answer. For example, if you give children a piece of paper and you show them how if you fold it into half in the middle, then you can say that now each side is half of the original paper. So this way you can introduce the concept of fractions. And again, if you fold it like this, it means that each side is now 1/4 of the original paper. So that way you are introducing the concept of fractions and how they are related to each other and how they are related to the original paper or the original number. Therefore, the last option is the correct answer here. If you pause the video here and read through the question, you'll see that this is a very simple question, and if you just read and understand the two statements, you'll be able to identify which one is correct, which one is not correct. The first one says, mathematics curriculum in primary school must progress from concrete to abstract. This is a correct statement because first, if you are teaching students concrete mathematics, for example, if I teach them the concept of numbers 1, 2, 3, 4, or I use some objects to represent this number, that is 1 apple or 2 apples and 3 apples. So this is a concrete way of teaching mathematics. It's only after this that you move towards abstract concepts like, okay, there is a number called x and if you add y. So these are all abstract concepts, right? So the easiest way to remember this is first you teach concrete and then you move towards abstract. So it should always move towards abstract from concrete. So this is a correct statement. The next one is primary class students start doing mathematics without thinking. This is incorrect. How can you do mathematics without thinking? You have to think what you're doing. If you're doing something without thinking, then you don't understand it. You're just mechanically doing it, right? Just because you have memorized it. Therefore, A is a correct statement and R is incorrect. Now, if you look at the answer choices, both A and R are true. No. Both A and R are true. No. A is true, but R is false. Yes. A is false, R is true. No. Therefore, option 3 is the correct answer here. According to the National Curriculum Framework 2005, that is NCF 2005, which is the most appropriate statement about classroom-based assessment in mathematics? Now, what is this classroom-based assessment? Now, classroom-based assessment is something that we have discussed in the CDP syllabus, which is also called SBA or school-based assessment. And this can also be a part of the continuous and comprehensive evaluation that is being discussed. Right? So now when we are talking about classroom-based assessment or continuous and comprehensive assessment, it means that students are not just being assessed for the purpose of giving them a rank or giving them a pass or fail, but students are being assessed because that evaluation itself is part of a teaching learning process. They are being evaluated individually so that we can understand what are the strengths and weaknesses of that specific child and not just to compare with somebody else. And in comprehensive assessment, there is teacher assessment, there is peer assessment, there is external assessment, and there can also be self-assessment, right? Therefore, now that we know what are the basics of comprehensive and continuous evaluation and school-based assessment, let's look at the answer choices. The first one says, it should not merely be done for evaluating the students, rather it should be done for providing feedback and improving teaching learning process. Now, this is school-based assessment, and this is also what is being used to describe continuous and comprehensive evaluation. Therefore, this is a correct statement. Next one says it must be done to rank students in classroom, which will help students to progress. Now, ranking of the students is done finally, right? This is summative assessment, which can be part of the comprehensive evaluation, but it should not be done only for that purpose. So this is not something which is prescribed by NCF. Therefore, this can be ignored. Next, it should not be part of the mathematical instructions but be done separately. No, this is also incorrect because the evaluation or the assessment should be part of the teaching learning process and it is not a separate process by itself. Therefore, this is also incorrect. And the last one, self-assessment is not possible in primary class. This is also incorrect because children should be given an opportunity to assess or evaluate themselves also in the continuous and comprehensive evaluation process. Therefore, only statement 1 is correct as per what is prescribed under the National Curriculum Framework. Which of the following statements is or are true about mathematics learning among primary grade learners? Now, the first statement says children come to school with some ideas about mathematics. This is true because even when they start kindergarten, children do have some idea about some numbers. They know that if they have more chocolates than somebody else or less chocolates than somebody else, so they have some idea about mathematics. Right? So this is a correct statement. Next, children's ideas about mathematics before coming to school are irrelevant for school mathematics. This is absolutely incorrect because the ideas that children already have about mathematics, about numbers, the concepts that they have already thought of, understood, they might either be correct or incorrect, but they definitely influence what they are going to learn in the school. If what they have already learned before coming to school is correct, then the school can build upon that knowledge. If what they have learned before coming to school is wrong, then that part has to be unlearned so that the correct technique or the correct concepts can be taught in school. Therefore, whatever ideas children have about mathematics before coming to school is relevant and important in school mathematics. Therefore, this statement is incorrect. Next, children develop spatial understanding only while studying geometry. This is incorrect because children might be playing, and when they are playing, they will throw some objects. They might throw a ball. So if they are throwing a ball, they are developing an idea as to what is the distance between me and my target and how fast or how high should I throw the ball to hit the target. So this spatial understanding, right, thinking in 2D or 3D is something that they will learn in various activities and not only while studying geometry. Therefore, this is an incorrect statement. And the last one is children in primary classes are able to identify shapes in their surroundings. This is correct because either you teach them in school or they might have learned things before coming to school. They are able to identify a circle, a square, a rectangle, a triangle because they might have played with toys which are triangles. They might have played with toys which are circles. Therefore, they are able to identify shapes in their surroundings. Therefore, A and D both are correct. So when we look at the answer choices, A and D are correct. According to the National Curriculum Framework of 2005, important feature or features of mathematics curriculum are what? So now let's read through all the options. The first one says it should be ambitious and coherent. Now coherent means there should be some logical connection between the different chapters, and there should be some connection between what is being taught in theory and what is applicable in real life. And it should also be ambitious. In a sense, it should not be just about meeting some basic requirements. It should try to improve the learning and understanding of the students. So it should be ambitious and it should be coherent. It should be relevant. So this is a correct statement. Then it should be activity oriented. If it is only theory oriented, the children will become bored very soon. So it should be activity oriented. So this is correct. And it should include more number of summative assessments. Summative assessments means like the annual exam or the monthly tests or the weekly tests, right? So if you are using a lot of summative assessments, then this is not something that is recommended under the continuous and comprehensive assessment that is recommended by NCF. Therefore, including more number of summative assessments is not ideal. Next, it should emphasize on procedures and knowledge of formulae over understanding. Now this is completely incorrect, because if there is no understanding and if you emphasize procedures and knowledge of formulae over understanding, then they don't actually understand, they might actually just be able to memorize the formulae. Therefore, D is incorrect. So only A and B are correct. Therefore, option C, which says A and B, is the correct answer. The most appropriate example of student-centered classroom in mathematics is what? Now, you have to pay attention to the most appropriate here. This word has been given here, most appropriate, because there can be more than one correct answers here, right? And we have to identify the strongest example or the most appropriate examples. Now, the first statement says providing multiple questions to every student in the class for practice. Great, you are providing lot of practice, but this is not a good example of a student-centered classroom where the child is given a lot of importance, more importance than the theory and more importance than the curriculum, right? Therefore, here you are just providing multiple questions to every student for practice, so it is not a student-centered classroom. So let us ignore this. Next, teacher is asking every student to solve the problem on the blackboard. Fine, this is great, but you are just calling the students and making them solve a problem on the blackboard. So what if some of the children have not understood the concepts? What if some of the children are very afraid to stand in front of class because they have stage fright and they are not able to explain? So while this is a good activity and it has to be conducted in the classroom, but this is not the most appropriate example of student-centered classroom. Therefore, let us ignore this as well. Next one, teacher is engaging with the students in the classroom to build their mathematical understanding from their personal experiences. Now this is a very good example of a student-centered classroom, because when you engage the students in an activity, right, in the classroom, and you build their mathematical understanding on the basis of their personal experiences. For example, if I talk about shopping, then I ask the students, you explain, when did you go to a shop, what did you buy, what did you see there, did you see anybody paying money, what did you buy? So I'm trying to see what kind of experiences people have or children have in their real life, in their personal life, and using that I will connect it to the theory that is being taught in the classroom, so that the theory that they are studying can be used in real life. So I'm engaging the students, I'm understanding their personal experiences and connecting the mathematical teaching or the theory with their personal experiences. So this is the best example of a student-centered classroom where the student is being given the utmost importance. The next one, teacher is solving the problem on the blackboard and explaining the algorithm to the students. This is teacher-centric classroom, because here it is more of a one-way communication, because the teacher is standing in one place and solving the problem on the blackboard and explaining it. Now, how does she make sure that the students have actually understood it? So the students are not actively participating here. So this is teacher-centric and not student-centric. Therefore, only option C is the most appropriate example here. Which of the following is or are most appropriate about the mathematics textbook for primary classes? Now, pause the video and read through these three statements A, B and C. And you'll see that statement B says that the language used in the textbook must not be far removed from everyday speech of the student. That is, that language used in the textbook or the examples used in the textbook must be relatable or connectable to the everyday speech and the everyday experiences of the students. So that way students are able to connect the theory to the real life and they'll be able to understand it better. So B is a correct statement. If B is correct, then any statement which does not include B, any answer which does not include B can be eliminated. So we can eliminate only C. Right? Now the next thing that we can evaluate is that the books should not include stories and other narratives, rather should include only a lot of questions to practice. Now if the book has just a lot of questions for practice and does not include stories, does not include narratives, then the book will become very, very boring. Right? And if it is very, very boring, children will lose interest in this subject. Therefore, books should include some stories and narratives if you are trying to teach mathematics to primary class children. Therefore, C is incorrect. If C is incorrect, any option that has C in it can be eliminated. So only C has been eliminated and B and C can be eliminated. Now we have to see whether it is A and B or only B. Now statement A says the problems given in the textbook should reduce solutions to knowledge of specific tricks. Now let me give you an example here to illustrate what this statement means. To write 9 table, right, all you have to do is write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and the other side just write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and you can see that 9 ones are 9, 9 twos are 18, 9 threes are 27. Like that you can write the 9 multiplication table. Now that is a trick that I am giving you to remember 9 multiplication table. So if I tell you this, you will be able to do 9 multiplication table perfectly. But if I am not teaching you the basics of what is multiplication, how do you arrive at this 9 or 18 or 27, then you will be just able to solve only the 9 multiplication table. If I give you any other multiplication table, for example 6, you will not be able to solve because that does not follow the same trick. So here, if problems given in the textbook are reduced to solutions which use specific tricks, like how you remember 9 table, then you'll be able to solve only that problem and not solve any other problem where the basic details are changed. Therefore, understanding the concepts, understanding the basics is more important than the specific tricks. Therefore, A is incorrect. If A is incorrect, then we can eliminate option A and only B is the correct answer here. Which of the following is not related with the process of mathematics teaching and learning? Now, there are a number of processes that are part of the mathematics teaching and learning, that is abstraction or estimation or investigation, logical thinking, memorization, optimization, organizing. So all such processes are used in mathematics. Therefore, they are part of the mathematics teaching and learning. Now we have to identify which of these given options is not related to the process of mathematics teaching and learning. So abstraction is included, investigation is included, optimization is included, rote memorization is not included, because rote memorization means memorizing something without understanding the basics, right? Without understanding what it is all about. So by rote memorization you will just remember that, but it is not necessary that you have actually understood that. Therefore, rote memorization is not related to the process of mathematics teaching and learning. Now you might ask me a question, memorization is mentioned in the list that I have put in, right? So what is the relationship between memorization and rote memorization? Well, the difference is this word rote. Rote signifies that you have not understood it, you have just memorized it. Now if I memorize some tables, for example if I memorized the 8 table, right? Now it means that I know multiplication, but for making my life easier I also memorize the table. So even if I don't remember the specific table, I'll still be able to multiply say 8 into 7 and arrive at the answer, right? So memorization is not rote memorization. Memorization can be after you have understood something, whereas the word rote memorization specifically means that you have not understood it, you have just memorized it. Therefore, rote memorization is not related to the process of mathematics teaching and learning. Which of the following is not a step of Polya's problem solving model? So now Polya's problem solving model has 4 distinct steps. First is to understand the problem. If you don't understand, you can't do anything further. Next is to devise a plan as to how you will solve the problem. then to carry out or execute the plan, and after that you will look back or review to see what have you achieved and if there are any changes that are required, if you have any feedback or learning from that execution. Therefore, these are the 4 steps: understanding, devising a plan, executing the plan, and then reviewing or looking back. So now if you look at the answer choices, understanding the problem, first one, yes. Devising a plan is also included, and looking back is also included, right? So 3 of them are included. Memorizing the algorithm, right? This is to just remembering the algorithm without actually understanding it. That is definitely not part of Polya's 4 problem solving steps. Therefore, this is the answer to this question. While adding 3 numbers given as below, a student calculates in the following manner. So the student is supposed to add 73, 35 and 27, and the problem has braces around 73 and 35. So he is supposed to add this first and then add the sum to 27 to get the answer. But what he does is he moves the 35 to this side and 73 to this side, and then he adds 73 and 27 first because it's easy to add them, and they add up to 100. So then he adds the 100 to 35 and he gets 135. So we are supposed to identify which are the properties of addition of numbers that the student has used. Now if you look at it, here the student has first moved the 35 from this side to this side and the 73 to the other side. So these numbers are commuting, they are traveling, they are changing places. So first he is using commutative, and then if you look at it, originally the association was between 73 and 35, but he changed that association to 73 and 27. So he is making use of the associative property of addition of numbers. So he is using commutative first and then associative. So when we look at the answer choices, commutative and associative, this is the correct answer. A student solves the problem on multiplication in the following way, right? So the student is supposed to multiply 35 and 23. So what he does is he writes it in this form which looks like addition, right? And he is multiplying 5 into 3 and he gets 15. So he is writing 5 here. He is taking 1 carryover, and then 3 2s are 6 plus 1 is 7. So this way he is trying to do this multiplication problem of two-digit numbers by using a process that looks very similar to addition. Now we have to identify what is the most probable reason for the error made by the student. The first option says the student is unable to recall the multiplication tables up to 10. This is incorrect because if you notice 5 3s are 15, he has done it correctly. 3 2s are 6, he has done it correctly. So he knows multiplication table. So we cannot prove that he does not know multiplication table up to 10. Therefore, this is incorrect. Next, the student has extended the algorithm of addition to multiplication. Now, if you notice, the process that he has used is very similar to the process of addition, right? So he has used the algorithm of addition to try and do this multiplication problem. So this is the best answer because that is the most probable reason for the error. Next, the student does not know the algorithm of addition. This is incorrect because he has added 3 2s are 6 plus 1 7. So which means that he knows the algorithm of addition. So this is incorrect. Next, the student is unable to do regrouping of numbers while multiplying numbers. This is also incorrect. So all that the student has done here is he has tried to use the algorithm or the process of addition to try and do a multiplication problem. So that is the most probable reason for the error. And with that, we have completed the 30 questions from this previous question paper. If you have any questions or feedback, please put them in the comment section below. And please do like, subscribe and share this video. I will see you again in the next video where we will solve more questions from previous question papers. Till then, take care, stay safe.